Hi, welcome back. This is Professor Ridge, and today's lesson is on section 4.5, rational functions. A rational function is a function f that is a quotient, or we can say ratio, of two polynomials. That is, so we have f of x is a rational function. It's a ratio of two polynomials, so p of x over q of x. Where p and q are polynomials, and of course q of x can't be 0 because we know that's undefined. And then the domains can be all the inputs x such that q of x is not equal 0. Okay, so determine the domain of f. So if f of x equals x squared plus 3x minus 10 over x squared plus 2x, the domain is all x's such that q of x, that's the denominator, is not equals does not equal 0. So our domain is going to be x squared plus 2x does not equal 0. So we solve this. You factor out the x plus 2. So x cannot equal 0. And x plus 2 cannot equal 0. We solve that one, subtract 2. So that would be negative 2. So our domain is set of all, if I do the interval notation, it's from negative infinity to negative 2. Oops. Domain, negative infinity, negative 2 to 0. Union 0 to infinity. So that's everything but negative 2 and 0. Okay, and that's all we needed to do for that problem. So in this section we're going to be graphing rational functions, and the first step is typically we find the domain like we did up there, and then also we look for the asymptotes. Okay, so determining the vertical asymptote for a rational function f of x equals p of x over q of x, where p and q are polynomial functions. Now here's key, has no common factors, so we're saying it's reduced. Okay, so if we reduce it, anything that's left in the denominator, if you set that equal to 0, if a is a 0 of the denominator, then the line x equals a is a vertical asymptote of the graph. Okay, so an example would be if I had f of x equals x plus 2 over x minus 3. That's reduced. You can't factor it and cancel common factors. So anything that makes x minus 3 equal to 0, which is 3 is a 0 of the denominator, then that tells me x equals 3 is a vertical asymptote. So I better tell you what a vertical asymptote is. So the line x equals a is a vertical asymptote for the graph of f if any of the following is true. Now basically what we're talking about is what's happening as your x values get closer and closer to this a. So as x goes to a, let's say, and this, so this a from the negative side, meaning from the left side. So as you approach a from the left side, your y value, okay, so as x approaches a from the left side, f of x goes to either infinity or negative infinity. So let me show you a picture of that. So if this line is x equals a, and we're approaching it from the left side, you might get something like that. So you can see as we get closer and closer to a from the left side, it's this line is going up to infinity. Okay. Also, could go to negative infinity. So one or the other happens. You can't get both because then it wouldn't be a function. Okay, so you get one. So on the left side of A, as you get closer and closer to A, your graph is either going to infinity or negative infinity. So it might be something like this. Okay? And then on the right side, same thing. As x goes to A from the right side, this is notation that if you go on to calculus, we'll use this in calculus. As x goes to A from the right side, f of x, remember that's the y value, goes to infinity. So it might look something like this. So we're approaching it from the right side, so it'll be coming from this side. Okay, so again, it's going up to infinity. And then the last case, as x goes to A from the right side. Now it doesn't matter if A is a positive number or negative number. You're looking at the positive A with the plus up there. You were saying from the right side of A. F of x goes to negative infinity. And so that would look like oops, let me write it over here. That would look like that. Okay, so it's going down to negative infinity as you get closer and closer to A from the right. Okay, so if you get any one of those four cases, then that vertical line is an asymptote. And what we're saying is, basically, if you were to zoom in on it real close to A, it starts resembling that line. It gets closer and closer and closer to that line. All right, let's try an example. So now remember, to find the vertical asymptote, you need to write f of x in reduced form. So we can factor an x out of the bottom. And notice the zeros of the function are x equals 0. I mean, the zeros of the denominator are x equals 0, x equals negative 10. But if you notice, this is not reduced, so we have to reduce it first. So f of x equals 4 over x plus 10, provided x is not equal to 0, right? Because if x is equal to 0, in the original function, if x is 0, it's undefined, right? F of 0 is undefined because you get 0 over 0. But if you put 0 into the reduced form, you get 4 over 10, which is 2/5. So they're not equal at that spot. So you have to note it, and when we get to graphing that, what you do is you put a hole, you put a blank spot there, and a hole at x equals 0, 2/5. An open circle. All right, we'll talk about that later. We're concerned with vertical asymptotes, so you have to reduce it. Okay, when anything that cancels out, you got to make note that x can't be equal to whatever 0 is that you're canceling out. And then the vertical asymptote is what's left over equal to 0. So vertical asymptote x minus 10, you set it equal to 0. So x equals negative 10 is the vertical asymptote. And again, at the graph where you make a vertical line at x equals negative 10, and you'll get one of the cases on the left side above. So it's either going to go to positive infinity or negative infinity. And then on the right side, you get one of those two cases. It's either going positive infinity or negative infinity. So you just plug in some test points to see which way it goes. Okay, let's try another one. So we're going to factor this to see if we can reduce it. So f of x equals x plus 5 over factor 32, let's subtract the 4. Well, that's 4 and 8. bigger one's positive, signs are different. Okay, nothing reduces, so it's reduced. Nothing cancels, so it's reduced. So we set the bottom equal to 0. Find the zeros of the denominator. So x minus 4 equals 0, or x plus 8 equals 0. X equals 4, or x equals negative 8. So our vertical asymptotes are x equals 4 and x equals negative 8. So when we get to graphing this, basically, let me just show you real quick. I'm going to go to 4, 1, 2, 3, 4, vertical line, go to negative 8, just pretend it's up there, and then on each side of the line, I'm going to get one of the cases either going to infinity or negative infinity. So it may be this one or this one of those. And then the way I would figure out is I just pick like 7.5 and plot that, plug it into the equation, plot it, and then I'll know which way it's going. And then on the right side, same thing. It's going to be either going to infinity or negative infinity. So it's one of these. And then the same thing for x equals 4. It's one of these. Just one, and then same thing on the right side of 4. One of those. Okay? And again, the way we'll figure out, we'll just plug in a point like 4.5, 4.1, and see if we're going to positive infinity or negative infinity. Okay? And we'll do an example in a little bit. Okay, so horizontal asymptotes, the line y equals b is a horizontal asymptote of the graph of f if either or both are true. So now we're looking at what's happening at the ends as we go to negative infinity, as we go to the left, or as x goes to positive infinity as we go to the right. Okay, so if either of these are true, as x goes to negative infinity, f of x goes to b. Now there's two ways that this can happen. You can do it from the top or from the bottom. Okay, so going to negative infinity, so let's say this is the line y equals b. Y equals b. Now, as x gets more and more to the negative side, we can go from the top, or we can go from the bottom. So you're going to get one or the other, not both. Okay, so just one. Just one. Otherwise it wouldn't be a function if you had both. Okay? And then for, as you go to the right, so again, if we have y equals b, whatever b is, we can get you're going to get just one of these. Okay? Again, the key is just one, otherwise it wouldn't be a function. Okay, so if either of those happens, then you say y equals b is an asymptote, or you can get both. Okay, so how do you find horizontal asymptotes? So if you have a rational function, f of x equals p of x over q of x, if the degree of p of x, that's the top, equals the degree of q of x, then the horizontal asymptote, is y equals a over b, where a and b are the leading coefficients of p of x and q of x respectively. So take the leading coefficient at the top over the leading coefficient of the bottom, and then you reduce that if you can. and then that y equals that number. That's your horizontal asymptote. Again, that's if the degrees are equal. So example would be if you had f of x was 3x squared plus 2x plus 1 over 2x squared plus 5. The degree of top is 2. The degree of bottom is 2. So those are equal to each other, so then the horizontal asymptote is y equals 3 over 2. Okay? Now, if the degree of the top is less than the bottom, so again, if the degree of the top, p of x, is less than the degree of the bottom, that's q of x, then the x-axis, or y equals 0, is the horizontal asymptote. Okay? So if the top is, say, this x plus 2, that's degree 1, and the bottom is x squared plus 5, x minus 7, then the horizontal asymptote degree top is 1, and the degree of the bottom, is 2, so the degree of the top is less than the bottom. So then our horizontal asymptote is y equals 0, or the x-axis. However you want to say that, doesn't matter. Same thing. Y equals 0 is the x-axis. Now, if the degree of the top is greater than the degree of the bottom, then there's no horizontal asymptote. Okay, so a line that is an asymptote but is neither horizontal nor vertical is called a slant asymptote or an oblique asymptote. Okay, so you do those words. And then you get an oblique asymptote if the degree of the top is 1 greater than the degree of the bottom. Okay, so a line that is an asymptote but is neither horizontal nor vertical is called a slant asymptote or an oblique asymptote. So a slant asymptote or oblique asymptote. And again, if the degree of the top is exactly 1 greater than the degree of the bottom, so the top is 1 more than the bottom, then the line y equals mx plus b is the slant asymptote of the graph. And the way you find the mx plus b is you divide the top divided by the bottom, you ignore the remainder, and then that quotient is going to be mx plus b, and that would be your slant asymptote. So let me show an example. So say f of x is 4x squared plus 5x plus 7 over x plus 1. And the way I do this, I can do, for this one I can do long division or synthetic division. If it's like at degree 3 over degree 2, you got to do long division. So I'll just do long division just to show you. 4x squared plus 5x plus 7 divided by x plus 1. So 4x squared divided by x is 4x. And we're going to subtract. So we get x plus 7. X divided by x is 1. Plus 1. Subtract. So that's 6. And then the remainder we throw away. We don't care about. This, y equals the quotient. Y equals 4x plus 1 is the slant asymptote. Or the oblique asymptote. This book uses oblique asymptote. Okay. Alright, so now let's now we've talked about all the asymptotes, let's talk about graphing these things. Okay, so first step is to find the domain, right? Find any real zeros denominator to determine the domain. Now remember, we need to reduce it. Anything that cancels out, you still got to note it in the domain. So like that first example I did where I canceled out the x, So in the domain, x cannot equal 0 still. And then anything that's left over, that's going to be your vertical asymptote. So determine the domain and sketch your vertical asymptotes. Okay, so the next thing we do is find horizontal or oblique asymptotes, if there are any, and then sketch it. You may or may not have any of those. If you do, sketch them. Okay, next, find the zeros of the function, and thus find the x-intercepts. Okay, so find the zeros function. So here they make notes. So you're going to set the top equal to 0. Set numerator equal to 0. Okay, and solve that. And then plot the x-intercepts. And again, the x-intercepts are, the x-coordinate is a 0 for x-intercepts. So if you have 3 zeros, say 1, 2, and 5, then it's going to be 1, 0, 2, 0, 5, 0. Okay, I'll show you in a second. The next thing is find the y-intercept. So you're going to find the x-intercepts, that's step 3, and then you're going to find the y-intercept, step 4. And there's only one of those, and sometimes there's not any, depending on if you have a vertical asymptote there or not. Okay, so that's basically I'm saying find f of 0, right? You plug in 0 for the x to find the y. So you're going to plot 0, whatever f of 0 is. Right, that's your y-intercept. And then the last step is you're going to find other function values to get you the shape and then sketch it. Try this one, f of x equals x minus 1 over x squared minus 1. We're going to graph it. Now our first step's the domain. So remember, the domain is where the bottom is equal to 0. You got to throw, that can't equal to 0. So x can't equal to 0, right? If we factor it, it's x plus 1, x minus 1. So x cannot equal negative 1, x cannot equal positive 1. So the domain is negative infinity to negative 1, union negative 1 to 1, union 1 to infinity. So we got those two spots that it can't be. 1 and negative 1. And then we also want to talk about vertical asymptotes. So that's if we take f of x in reduced form, and notice the bottom's x plus 1, x minus 1, if we factor it, that cancels out, so we get f of x equals 1 over x plus 1, provided x is not equal to positive 1, because that's the one we canceled out. We canceled out x minus 1. If we put 1 into this reduced function, see you get, no, if you plug 1 into here, it's 1 over 1 plus 1, which is 1/2. But if you plugged 1 into this one, oops, f1, you would get 0 over 2 times 0, which is 0 over 0, which is undefined. So that's why you have to make note of that. And so what's going to happen is a vertical asymptote, we're going to have a vertical asymptote at the one that didn't cancel, x equals negative 1. And we're going to have a hole at x equals 1, which is 1. And then you plug in 1 into the reduced function, which would be 1/2. And we're just going to put an open circle there. Okay, so we're going to have a vertical asymptote at x equals negative 1. So we're going to put in our dashed line through x equals negative 1. And then we're going to have a hole at 1, 1/2. We'll put an open circle there. Alright, Now step 2 is we're going to look for, we're going to look at the reduced form, and we're going to graph the reduced form now, and we made the notation of the whole at 1, 1/2. So that's the only difference between the two graphs. Alright, so now what we do is horizontal asymptote. If the top is smaller than the bottom, degree 0, right, you got degree 0, which is less than the bottom, which equals 1. So that means the x-axis is my horizontal asymptote. Y equals 0. Right? So the x-axis is the horizontal asymptote. Just remember that. And then step 3 is find the zeros of the function. So find zeros. We want the x-intercept basically. So you're going to set the top equal to 0 and solve it. Well, right, there's no solution there. And that makes sense because we just said that the horizontal asymptote is the x-axis. Well, that's not true. You can cross the horizontal asymptote. Okay, so there's no x-intercept. And then step 4, we want to find the y-intercept, which we put in 0 into the function. And we can put in either the reduced form or the original form, doesn't matter. The reduced form's easier. 1 over 0 plus 1. So we get, if x is 0, y is 1. So plot that point. And then now we're going to plot some, now we're going to use our knowledge about the vertical asymptote. So as we approach it from the left, so what I'm going to do is I'm going to do like f of -2 and plot that point. I'm going to put it in the easier form, the reduced form. So we got -2, -1. And actually now I kind of know what's going on just from that 1. You'll notice as we get more negative, we're going to start approaching the horizontal asymptote, which is the x-axis. So like 3 is going to be 1 over -3 plus 1 is 1 over -2. Right there. If we did -4, f of -4, you get 1 over -4 plus 1 is -1/3. And you see what's happening now is we have this horizontal asymptote, so it's going to y equals 0 as we get more and more negative, right? Now as we approach x equals -1, so like if I did f of negative from the left side, -1.5 for instance, and plug that into my calculator, I get -2. And you should see that, okay, that's going to go to -infinity, and you can keep plugging more numbers in. All right, now if we do like f of say -0.5, we're going to get 1 over -0.5 plus 1, which is 1 over 0.5, which is 2. And you should see what's going on here, that we're actually going to go to our vertical to positive infinity. And then as we go out to, as x gets bigger and bigger and bigger, you can see that, let's say if I put x as 4, I'm going to get 1 over 4 plus 1, which is 1 over 5, which is 0.2. And you should see that what's going on this side is now we're approaching the horizontal asymptote. Okay, and so that's what that graph looks like. Okay, let's try another one. Okay, so here our domain's going to be x cannot equal -3. So we met bottom, set the bottom equal 0 and solve it, and then throw those out. So that'll be negative infinity, negative 3, union, negative 3 to infinity. Vertical asymptote, so that's reduced. There's nothing to do. So vertical asymptote is x equals negative 3. So let me draw that. Okay, so we got vertical asymptote x equals negative 3. We'll put a vertical line there, dotted line. Oops. Okay. Now horizontal asymptote, degree at top is smaller than the bottom. So that's going to be y equals 0, or the x-axis, however you want to think of that. So that's the x-axis. And then we're going to look for any x-intercepts. So that's where the top equals 0. So we're going to go 2 equals 0. Well, that's no solution. So there's no x-intercepts. Y-intercept, we're going to put in 0. So that's 2 over 3 squared. So that's 2/9. So y-intercept is 0, 2/9. Right about there. And then we'll plot some points and keep in mind vertical asymptotes. So remember, the horizontal asymptotes we're either going to get, so for horizontal asymptotes going out to negative infinity, we're going to get either this one or this one of those two. So the way we figure that out is just plug in some points and see what's happening out there. So if we do negative 6 or negative 5, negative 4, it doesn't matter. So if we do f of negative 4, we get 2 over negative 4 plus 3 is negative 1 squared, so we get 2. If we put f of negative 5, we get 2 over negative 5 plus 3 is negative 2 squared is 4, which is 1/2. So we get 1/2. If we do 6, negative 6, we get 2 over negative 6 plus 3 is negative 3. Negative 3 squared is 2/9. And you should see what's going on. So as we go to our asymptote, horizontal asymptote is that one. And then you can see as we get closer to x equals negative 3 from the left, it obviously has to go to positive infinity. If you're not sure, plot like negative 3.5 and you'll see that that's what we get. And then now let's look at the other side. We got, let's try f of negative 2. We're going to get 2 over negative 2 plus 3 is 1. 1 squared is 1. 2 over 1 is 2. So negative 2 is 2. If we do negative 1, you get 2 over 2 squared, which is 2/4, which is 1/2. And if we did our, there's some symmetry going on here, but anyway, we won't talk about that right now. So we get that same idea. There you go. All right, let's try a little bit harder one. Next page. Okay, so this graph f of x equals x squared over x squared minus x minus 2. So first thing we want to talk about is the domain. So we're going to set the bottom equal to 0. Well, it can't be equal to 0, so we factor that. Factors the 2, subtract the 1. So x can't be 2, and x cannot equal negative 1. So our domain is negative infinity to negative 1, union negative 1 to 2, union 2 to infinity. And And if we look at f of x in factored form and see if we can reduce it, x minus 2, x plus 1, nothing reduces. So our vertical asymptotes are x equals 2 and x equals negative 1. Okay, so let's sketch those. Okay, so x equals negative 1. We'll put a vertical line there. And then x equals 2, vertical line there. So those are vertical asymptotes. So remember, as we're going to the left of each side, it's either going to infinity or negative infinity. And then on the right, same thing. Okay, and you only get one on each side. Okay, horizontal asymptote. Degree of top equals degree of bottom. So that means y equals the leading coefficient over the top or the leading coefficient of the bottom. So y equals 1. Y equals 1. So we put a horizontal line there. Y equals 1. And then, so again, as we go to negative infinity, the graph is approaching that line. As we go to positive infinity, same thing. You're getting closer and closer to 1. Alright, x-intercepts. So we let the top equal 0. So x equals 0. So 0, 0 is our x-intercept, which of course will be our y-intercept too, because you can only do one. Because you put in 0, you get 0 over negative 2, which is 0. Okay, so we got 0, 0. And then now we're going to plot some points so we can see what's going on in the asymptote. So if I plot like negative, so basically I'm just doing x and y, right? So if I do f of 0, 0, let's do f of negative 4. Put in negative 4, we get 16. I'm just plugging it into the equation. 16 over 16 minus 4 minus a minus 4, so that's plus 4 minus 2. So that is, I'm plugging it in, 16 over 16 plus 4 minus 2, which is equal to 16 over 18. And that's a little less than 1, so it's right about there. Now that gives me enough information, but just to, you know, if you're not sure, f of negative 2, plug it in, we get 4 over 4 plus 2 minus 2. Wait, did I do that right? 4 over 4 plus 2 minus 2. So that is 4 over 4, which is 1. Oh, that's a good point. Actually, I didn't have enough information there. I know as I get further out here that this is going to go to, this is going to that way. But what's happening over here, I better plot a couple more to see what's going on. F of negative 3. So that's a misconception. A lot of people think that you can't cross a asymptote, but horizontal asymptotes, yes, you can. We're just talking about what's happening at the extreme ends. In the middle, I can cross it, right? But at the extreme ends, I'm getting closer and closer to it. So f of negative 3 is 9 over 9 minus 3. Actually, it's easier to put it in the factored form. So we get negative 5 times negative 2 is 10. Nine plus 3 is 12, minus 2 is 10. Yep, 9/10. So it's getting closer here. If I did f of negative 2.5. Let's plug that in. So if I punch that in my calculator, oh, actually I don't care about that one. I don't care. I want negative 1.5. I want to get closer to x equals negative 1. And that gets 1.28. And if I were to get closer, you would see that it's going to go up. So I'll let you look for like negative 1.1 if you're not sure. Okay, so it goes that way. Now, what happens at like negative 0.5? So we plot f of negative 0.5. And we get negative 0.333, 1/3 basically. What's going on there is this is going to do that, go down to infinity there. If we do f of 1, we get 1 over 1 minus 1, just plugging it into the function. So you get 1 over negative 2, so negative 1/2. And then I kind of know what's going on. And then now let's do f of 3. F of 3 is 9 over 9 minus 3 minus 2. 9 over 4, so that's 2.25. And then if I do f of 4, that's going to give me 16 over 16 minus 4 plus 2, which is 16 over 14. That's a little more than 1. So over here, this is what's going on. Okay, so that's that graph. Alright, let's do one more. So example, graph f of x equals x squared minus x minus 2 over x plus 2. Okay, so the domains, well, we got to factor it. So let's see. Well, I guess we don't have to factor it for the domain. Okay, so the domain is going to be x plus 2 cannot equal 0, so x cannot equal negative 2. Now we need to factor this to make sure that for the horizontal asymptote, vertical asymptote's there. So we get domain is negative infinity to negative 2, union negative 2 to infinity. We want to look at f of x factored, just make sure it's an asymptote. Factors of 2. Let's subtract the 1. Okay, nothing cancels. So our vertical asymptote is x equals negative 2. Let's draw that. Okay, so x equals negative 2. Horizontal asymptote, degree at the top is bigger than the bottom. So none. No horizontal asymptote. Top is 1 more than the bottom, so there's a slant asymptote. So we're going to do the long division. Actually, we can do synthetic division with this one. Well, I already wrote it, so no big deal. Yeah, let's do synthetic. So remember, that's negative 2. You change the sign. And we do 1, negative 2. And we get 1. It's negative 2. Negative 3, 6. We don't care about the remainder. So y equals 1x minus 3. So we're going to graph that one. Slope is, y-intercept is negative 3. And slope is up 1 over 1, up 1 over 1, up 1 over 1. So on. Down 1 over 1. 1, down 1 over 1. And remember, this is a slant asymptote. Oh, I did. I'm going to run out of room. Because I have a feeling my graph is going to be down in this corner here where you may not be able to see it all. Alright, so vertical axis, now we got to look for x-intercepts. So that's where the top equals 0. And let's look at the factored form because that's easier to do it. So x equals 2 or x equals -1. So that's 2, 0, -1, 0. 2, 0 right here, -1, 0 right there. And y-intercept, we're going to let x equals 0, 0 minus 2 over 2. -2 over 2 is -1. So there's the y-intercept, 0, -1. And okay, I kind of know what's going on just because I've done a bunch of these before. If you're not sure, plot some points. So if we get f of, say, -1.5, and we plug it into the function, and we get 3.5 there. So you can see what's going on here, I think. And if you're not sure, you can plot 1, f of 1. That's a good one, f of 1. So we're going to get 1 minus 1 minus 2. 1 minus 1 is 0 minus 2 over 3. So -2/3. And since that's a slant asymptote approaching that line as we go further out to the right, as we go out to positive infinity. Okay, now going from negative, say like f of -3, f of -3, plug that in and you get negative, so we get 9 plus 3 minus 2 over -1, -3 plus 2, so 12, that's 10 over -1, so -10. So that's what I'm saying. I'm off my paper. So 1, 2, 3, 4, 5, 6, 7, 8. Yeah, you can't see it. So basically the ends are going to do that. I can't hit it, -10 down there. So let me just draw a little mini sketch of what this will look like. So it's something like this down in that bottom corner. And then of course we got, oops. Okay, so it should look something like that. Alright, so, and I don't want to rewrite it, so hopefully you got the main idea. I wanted to show you that example for the slant asymptote. Y equals 1x plus or minus 3. That's your slant asymptote. Okay, so that concludes the lesson for 4.5. Go to my math lab and complete your exercises there. See you next time.